Hey guys and gals. We are going to use our LeverLinks file here to learn a little bit about ways of setting up levers and linkages in mechanics, and also to practice our OnShape assemblies. Okay, so I've created this set of parts for you all to work through the problems on our worksheet. All right. Now in this video, I'm going to show you, we'll work through problem number 1, and I'll show you how to set up some mates so you're set to go. Okay, first thing, notice we are in the assembly called starting setup. The parts are over here. Don't mess with the parts because they work the way they are, but starting setup is what you want to use. Now I recommend highly to right-click starting setup and duplicate it, and make copies to work in, so you always have a basic setup here that's untouched that you can always use for the next problem. Okay, so it's easier to start from scratch, I think, than to take apart a bunch of mates, etc. So I'm going to rename one of them problem 01, and in problem 01 we will go ahead and build the first assigned problem. So the assignment is the output's direction is opposite of the input, and the direction and the distance is the same. Okay, so distance is same, direction is opposite. So first thing I'm going to recommend for this one, I'm going to move the output over to the side here. Move it down a little bit. And I'm going to move the 50 pounder a little bit out of the way. Now, since the direction of travel is opposite, in my mind, we're going to use the straight bar for that, because that can create directions that are equal or opposite. So we're going to bring the straight bar into the middle of the field here, and I'll move our 90-degree bar down and kind of out of the way, next to the 50. The input bar we're going to use, and I'll leave him on this side, output bar on this side, and our two pins, our guide pins, we're going to put one on this side, and we're going to need one on that side. So this is my basic setup for the starting point here. All right, so let's start connecting. Now, in all of these problems, you're going to need to connect either the straight bar or the L bar to that center pin on the board. So let's do that first. Now, a tip real quick is always work from the top view. Okay, so I'm clicking the view cube over here on the right, top view. That's going to make sure that when you move things around, they're not getting misplaced. All right, so opposite direction and equal distance. So equal distance means that the distance from the input to the fulcrum is going to match the distance from the fulcrum to the output. So in my mind, I'm going to connect the center hole to the pin. So let's pick revolute mate. Let's pick the top of the pin. We're going to revolute that to the top of this center hole here. And that gets our central bar in place. And this should be able to spin around because the base plate is fixed, as you see here. So that's good. That's a start. Now, direction is opposite. Well, if I put our input bar over here, all right, I'm not sure if this is, if I put our input bar over here, come on, and if we push this in this direction, then the top is going in the opposite direction. So that means we need to connect our output to one of the holes in the top of that bar. So let's put the output over there and the input over here. All right, get this one back roughly in position. So let's connect that. Now these have to be revolute mates as well, so everything can move. So we're going to revolute mate. Let's pick, for these, let's pick the mate connector in the middle of the post. You see the middle? And let's pick the top of the hole here. All right. Now, equal distance means, like I said again, that the distance from the fulcrum to the input matches the distance from the fulcrum to the output. So right now that's 2 spots away. So we need to connect our output 2 spots away as well. Okay, 1, 2. So our output needs to be revolute mated to this hole. So we're going to commit this first one and move on to another one. Center to top. And there we go. Now those are connected, input and output. When we push the input one way, the output will go opposite. Now the last thing we need to do is set up our pins to guide these bars so that way they stay, so you can move it around and see how this works. So we're going to use fasten mates. We're going to fasten the pins into the board. So let's pick the middle of the pin, and let's pick this hole. Put a pin down there. And let's put the middle of this pin, and we'll pick this hole here, and that is going to be the middle of this pin. All right, good to go. So we got those mates set up. And the final thing we need to do to keep these bars from sliding around where they shouldn't be, we need to fasten them in a way that they slide against the pins always. So for that, we're going to use this one right here, known as a tangent mate. So we are going to force the top edge of this to remain tangent with this surface here. And notice how now it's sticking to it. And we'll do the same tangent mate with our output bar. So we're going to pick the top edge, and we're going to force tangency to that surface. And we're going to accept that. All right, so now all our mates are set up, and we are ready to give it a shot. All right, so we'll go to top view. We're going to push the input, and the output goes the opposite direction. And the input, whoa, I pushed it too far on purpose. I was messing around. Come on, come on. All right, so let's pull this back around. All right, so the output goes in the opposite direction, and it goes the same distance. Okay, so if you look at the letters, we're on the U, we go to the N, and we're on the U, and we go to the, basically the end of the P there. So same distance, same distance, different direction. Okay? And you can play around with this, but that would be the answer to problem number 1. All right, so any questions on that? You can find me. Now, I would look at the worksheet and go to problem 2, and I would take another copy of this starting setup, and I would right-click, rename it problem 2, and I would build number 2 in here and try to set up something that achieves the goal of problem 2. Okay? And when you share this file with me, I'll look for problem 1, 2, 3, 4, and on and on. All right, have fun. Good luck, and I will see you later.